All right, so this is number 12 from your review. It's talking about, so it's asking us to, like, without graphing, to determine whether or not there's going to be point symmetry, line symmetry, or no symmetry at all. And if you recall some of those terms, they came from whether or not, like, our even and odd tests, okay? And so if you're thinking about kind of graphs of the past, right? So kind of your quartic maybe. Your quartic had one kind of symmetry, right? A regular old quartic kind of looks something like this. It's a little flat at the bottom and then comes back up. Okay, that is a graph that possesses line symmetry, right? In the sense that I can fold the graph over the y-axis and I end up getting the same graph back. Okay, so that's what we say line symmetry. So like even functions possess line symmetry. Versus not all the time, by the way, just about a line and the origin. A odd function would possess, and I think I've drawn this a couple times, maybe in class, but maybe I'll do it again here. An odd function like x cubed would have what we say point symmetry about the origin, right? In the sense that if I were to actually grab this, I gotta make it the same size, just give me a sec. If I were to grab this and kind of rotate it 180 degrees, we would expect to get the same graph back, right? So if this was properly drawn, I didn't draw it very well. It's not square either. But you can see as I rotated it 180 degrees, I do get the same graph back. And so that, by definition, is what we are calling point symmetry, where I can rotate a graph 180 degrees and get the same one back. So that's a clue that something is an odd function, right? So this is our even up top with line symmetry and odd down below, okay? We are interested in proving that all values of x abide by the law that we have, or the rule for testing even and odd, not just one specific example. So we're not just going to put in f at 1 and f at -1 because, and then see whether or not they come out to be the same answer, because it could be different for a different x value. So what we're going to do here is abide by our little test. So what we're going to do is check whether or not f of x if I input -x into my function, if something comes out to be even, then f of x needs to just come back again, right? The original f of x needs to spit itself out. That would be the definition of even, right? And by that I mean if we put in x, if we have x and -x, if I put in, let's say, positive x is what our original function is going to be. Let's say it's 5, for instance. And 5, when I input 5 into a function, it spits out positive 2. Okay? If I input the negative version of x, so let's say -5, -5 must also spit out a y value of positive 2 in order for the thing to be concluded as being even. Right? And that must work for all values of x along the x-axis. And so we're going to generalize this proof by inputting -x and not just a specific value of x. Okay, if I put in f at -x and I get a negative version of the function back out again, then I'm going to be in the instance of an odd function, right? So again, here, if I put in 5, and I have a point of 5, 2, and when I put in -5, right, as x, if I end up getting -5 and 2, -5 and -2, sorry, then that's what we are deeming to be an odd function. So you can see that the y value is kind of like a negative version of the original's y version. So there's a bit of rotational symmetry about the origin, and that's why we call it point symmetry. But again, this needs to work for all values of x along the x-axis, right? So we're generalizing. If neither of these two things end up happening when I evaluate at -x, and I get, I don't know, say something completely different, h of x. This, we are now in an instance where this is neither. And this typically happens when we have graphs that are not kind of orientated around the origin, I would say. Okay, so what we're going to do here is just use our test on A, B, and C, okay, to determine whether or not each of these functions is either even or odd, okay, and whether they possess line, point, or neither, line or point symmetry, or neither.